Yeah, but thanks so much for coming here and having me present to you all. It's a real pleasure. I'm Alex Washburn. I'm an industry professor of design here at Stevens. And before that, I was a chief urban designer for New York City under Mayor Bloomberg. Now, I was having lunch with Petra and Eva, and because of that... So with Petra and Eva, we were trying to discuss what urban design was. They are two young urban designers, so I felt I should begin with just a few slides on urban design, for all of us. And just to say that urban design, we're the ones who hold the pens. We're the ones in the center. We're the ones, that's the chief economist, the chief strategic planner, that is a community board liaison, the project manager. This is all back at the Department of City Planning in New York City, which is probably, it's one of the world's very best planning departments, I think, and I'm very proud of New York and its accomplishments and its ability to grow. But the urban design department, you don't need very many of us. There were about 15 of us in a department of over 300 people. But we're at the center, and what we do is combine politics, finance, and design and give it form. It's not that we're experts in the politics side or the finance side, but we want things to become reality. So there are many, many great designers in New York City, but there are relatively few urban designers, and that's because there are relatively few people who are willing to endure the bruises of politics and the appetite of finance in order to be able to inject their design into a system where it actually becomes reality. Now, even though we work at the scale of the city, oddly enough, the smallest dimensions matter. And those are two of my staff actually going out and measuring curb heights in the Bronx. The details matter because public space matters, and your perception of quality is based on details. So it became very, very important for us to know that. The way we would work, we had a saying that if it's worth remembering, it's worth drawing. So we communicate through drawing. And not only do we communicate with others, we communicate with ourselves. That's how we get public space physically inside of us. There's something about the action of drawing something. You don't have to be Michelangelo. You can draw stick figures. But if you observe a space and you draw it, it somehow gets into your head in a way that taking a photograph, reading the book, just can't. So everything we do, we would draw and walk. And finally, probably the most important aspect of this is the saying that listening is what changes a city. That's my old boss, Amanda Burden, an immensely powerful woman in New York, sitting through one of over 100 public meetings on our new waterfront plan. This willingness to listen is what builds trust and allows a system to have both bottom-up and top-down direction. Without this form of trust, without that form of communication, the planning will typically veer off to one extreme or another. So that was for Petra and Eva, and now I'll get back to our story here. So I used to work for Michael Bloomberg. I like to say I traded Bloomberg for BLUMBERG when I came to Stevens. Alan Blumberg is our professor of hydrodynamics at the Davidson Lab that you may have heard him mentioned a couple times. He's an internationally famous person who knows more about the movements of the water in New York Harbor than anyone else on the planet. I will tell you why that's very important to me, and that's why that drew me to Stevens. But here I just realized I have an out-of-place slide. That's my book. Should have been earlier. So sorry. The Rockefeller Foundation paid for it. It's out in paperback now, but it's a great book on what is urban design and most importantly, how do you apply it to make a city resilient? And the reason I asked that question is that my own house got flooded by Hurricane Sandy. I took so long to write the book that I became someone who had got to experience firsthand the ravages of a storm surge. And this is me going down. I stayed in my house, defied the evacuation order to see what it was like to actually be hit by a hurricane in a major urban city. And I walked downstairs. It was interesting. It was late autumn, so beautiful golden leaves, and the water was coming in fast, but it wasn't like a tsunami. And I went down to open the door, and then the leaves kind of just floated in, beautiful, gold, surreal, until, of course, I realized the electrical panel was in the basement, and then, boom, all the lights went out. Lights go out in the neighborhood. It was a humbling experience, And as much as you can believe in the power of New York City and the greatness of our technology and civilization, you just realize the scale is different. To see the Atlantic Ocean come and fill your city, and then when the Atlantic Ocean decided to leave, and you are simply part of the landscape. It's a new perspective. At other times we can talk maybe about some of the things that will keep us from embracing that perspective. Well, look, I'm a professor, so I get to digress. We sit on a set of environmental laws that are built on the premise that nature needs to be protected from us. They're based on pollution throughout the 19th and mid-20th century, the National Environmental Protection Act, NEPA, Clean Water Act, Clean Air Act, both brought into law in the early 1970s, all take the premise that we must protect nature from us. This is not the historical human perception of nature, but it's the perception of nature that is now operative in all our laws, and we have a big problem. Because now we realize that no, sometimes we have to protect ourselves from nature. But the way all our laws are written is they require environmental reviews and environmental approvals before anything major can be done. That prove that you have a finding of no significant impact on nature. But if you don't have a significant impact, you're not doing anything. So we are actually caught in the catch-22 that hasn't yet become public because not enough of the big projects have gotten to the point of needing approval yet. So just early warning, we will see in the next few years major problems, major hiccups in the public works that we are going to need to do in order to make ourselves resilient. Oh. That brings me back to Stevens. So I came to Stevens after Mayor Bloomberg left, after Hurricane Sandy hit, to start this lab, this center, this place of research, because I realized as good as the Bloomberg administration was, in the months after Hurricane Sandy, we just didn't have good data. We just didn't know what we were doing. And I felt that to understand what the right thing to do is, you had to combine three forces: hydrodynamics, to understand the force of the water; urban design, to understand the force of the city; and then finally complex systems, to be able to model that complexity, measure the results. And what you see here is actually a web feed from the Davidson lab. Professor BLUMBERG has over 200 sensors throughout New York Harbor. He has minute-by-minute feeds of wave direction, velocity, salinity, temperature. His work, he always likes to thank Newton. That Newton gave him the equations, the sensors gave him the data, and now he's able to translate wind and weather into waves. And to do it on the scale and a complexity, which I'll talk a bit later, actually gives you a tool to make a difference in the city. So an example of that, when Hurricane Sandy hit Hoboken, Professor BLUMBERG had already forecast where the water was going to go. But we didn't communicate that well. And so this guy, who had a fleet of taxis here next to the Hudson, said, oh my God, I better move my taxis as far away as I possibly can. And he put them back there, and of course if we had communicated correctly, he would have known that Hoboken used to be topographically an island. Storm surge came around from the back first. The fleet was ruined. So communicating is important, and we have this idea that maybe we could do something with Google, something a la Google Street View. And so we use me as a guinea pig. So this is my house in Brooklyn, and if you go to Google Maps and you type in 373 Van Brunt Street, Brooklyn, New York, you could go to Street View, see my house, zoom in, and then the analytics could kick in. Here would be our forecasted water level from the next storm that was going to come in. But probably more importantly, here's an uncertainty envelope, because we just don't know because of both the limits of science and the limit of our sensing. But something to bring it home is, what's the height of Alex? Now, if I had seen that relative to these forecasted levels, maybe I would decide whether to stay or to go. That's communication. It's fundamental to what we have to do. The background, of course, we all know that everything is going to hell in the sense of temperatures rising, precipitation getting more volatile, and sea level rising inexorably. So all our problems are exacerbated coming into the future. Some of the solutions, this is the Great Wall of Japan that's being built outside of Fukushima. I don't want that for New York. I don't think we should do this. This is perhaps solving the problem technically, but it is not improving the quality of life of people who live behind that wall. And that's one of our tenets, that we have to solve our resilience problems, but at the same time we have to make the city a better place to live. So I want to see something like this. And this is in Copenhagen. The water is 30 feet below. This happens to be from the old fort that was converted into a beautiful park. But the approach, the methodology here could be applied to Red Hook, where you could build polders offshore and have beautiful bodies of water behind them. You could landscape them. You could make the resilience feature also a park that would improve the quality of life. It would also allow opportunities for redevelopment, and that's a whole other section of what we do, which is to analyze the financial impacts. Remember, the politics, we talked about the regulatory set with the laws, but the finances, how do you get a neighborhood to afford this? There's no city in the world, not even Abu Dhabi, can afford to make itself resilient. You have to find a way of applying private money to these public purposes. Now that I'll talk a little bit about technology. My main focus now, and the focus of my research, is trying to figure out a way of getting project-level design input to have system-level effect understanding in real time. As I talk, I'll explain a little bit more, but this is a model here in this room of virtual Hoboken, where we've made a computer model of our city and hit it with the hydrology models developed by Professor BLUMBERG and his team across the campus. I want to give you a sense of how radical this is. Oceanographers typically work at the scale of hundreds of kilometers. Their grids are enormous. And Stevens has the Stevens North Atlantic Predictive Model, which does exactly that. But what Davidson does is, by using a series of nested forcing algorithms, is they get the grid down finer and finer to the conditions inside New York Harbor. And now they're gotten to be amazingly close to what I need. They've gotten down to 3-meter resolution. For me as an architect, I need 30-centimeter resolution, something the size of a door. But they're close, they're getting there. Firaz, as grad student, is actually working now on getting it down to a single pipe. It's very exciting. And it fits into the context of what I call surf and turf. It's an approach to this problem that seeks to combine solid modeling with fluid modeling, which is something that has not really been done very well before. And to do that, you need a representational space. And for me, the proper representational space is the city itself. And if you can build a 3-dimensional model of the city that is accurate enough, whose data architecture is flexible enough, then I think you have the basis for beginning to apply what is really a physics model onto the solid model, which becomes a terrain model. Here's an example, again, with virtual Hoboken. This is not a photograph. This is our InfraWorks model, built by LiDAR scans. And then this is not an actual condition, but it's a representation of a Sandy forecast by Professor BLUMBERG. Now, Alan likes to say, I can flood you, but I can't drain you. And what that means is that really inundation has two sides of it. Yes, there is a storm surge, which we focus on, but how you get the water away later is the sewer system, is your topography, is how you drain back into the ocean. So what we did last semester was with Professor Pujobi, who is an expert on sewers from Rome. So we modeled the sewer system of Hoboken, went underneath virtual Hoboken, and started inputting all these pipes and trying to sort out where they are so that we could now have an extra layer to our model that would let us know how the water could go back out. We also had some students going in and building prototypes of SEWERBOTS, because it's not enough to know where the sewer is, you have to know what condition it is. And rather than sending in undergraduates, it's probably advisable to build little machines that can go in and do it. It's a little more expensive, but they complain less. And we also then, here's some architecture students I was able to get from Syracuse University to come in and start working with our wonderful tools here to build in these shapes underneath. Speaking more about architecture, one of the projects we did, and this was with the firm NBBJ, is to come up with a parametric tool that would let you deal with communities and visualize how something could combine governmental objectives with techniques, typologies, walls versus berms, etc., and keep track of public costs and benefits, and do so in a way that would be visible to the public by using slide